These technologies were built to work. They passed tests, trials, and early demonstrations. Then, real conditions exposed limits that could not be ignored. They were not abandoned at conception. They failed only after coming close. And that made the consequences harder to contain. Technological systems are validated in controlled environments. Scale introduces variables tests cannot fully capture. Most technologies adapt. Some reach the edge of success and stop there. To understand how this happens, each case must be examined one by one. We begin with 10. Supersonic commercial flight. It was designed to reduce global travel time dramatically. Early aircraft proved sustained. Supersonic travel was possible. Noise restrictions, fuel consumption, and operating costs scaled faster than demand. Routes were limited by regulation. Economics undermined viability. Commercial supersonic travel stalled despite technical success. Next comes 9. Nuclear-powered civilian shipping. Reactors were adapted to power merchant vessels. Early ships demonstrated long-range endurance without refueling. Port access restrictions increased. Regulatory complexity multiplied. Public concern outweighed efficiency gains. The concept remained technically sound but commercially blocked. Moving on to 8. Large-scale carbon capture systems. They were built to remove emissions at industrial sources. Pilot projects demonstrated capture was achievable. Energy requirements increased operational cost. Storage infrastructure lagged deployment. Net reductions proved marginal at scale. Adoption slowed despite engineering feasibility. Now we reach 7. Fully automated highway driving systems. They were designed to eliminate human error. Controlled tests showed high reliability. Edge cases multiplied in real traffic. Environmental variability degraded performance. Human supervision remained necessary. Full autonomy stalled short of deployment. Next is 6. High-altitude wind energy platforms. They aimed to access stronger, consistent wind currents. Prototype systems generated sustained power. Maintenance complexity increased at altitude. Weather variability stressed tether systems. Grid integration proved difficult. Scaling halted before commercialization. Halfway through the countdown brings us to 5. Maglev passenger rail outside Asia. Magnetic levitation delivered high speed and low friction. Test lines demonstrated performance advantages. Infrastructure costs exceeded conventional rail. Route inflexibility limited expansion. Political support weakened under budget pressure. Deployment stopped despite operational success. Continuing the countdown, hydrogen-powered passenger vehicles. They promised zero-emission transport with fast refueling. Early fleets operated successfully. Fuel infrastructure remained sparse. Production costs stayed high. Energy efficiency lagged battery systems. Adoption plateaued without network support. Now only 3 remain. Smart grid demand response automation. Systems were designed to balance energy load dynamically. Pilot programs stabilized local networks. Consumer adoption remained inconsistent. Legacy infrastructure limited integration. Cybersecurity concerns increased oversight. Expansion slowed despite measurable benefits. Just before the final one comes too. Civilian supersonic land transport concepts. They aim to combine speed with accessibility. Test vehicles achieve target velocities. Safety margins narrowed at scale. Energy efficiency dropped rapidly. Noise constraints restricted corridors. Deployment remained theoretical. And finally, 1. Nuclear fusion power prototypes. They were designed to deliver limitless clean energy. Experiments achieved sustained fusion conditions. Energy input still exceeded output. Materials degraded under prolonged exposure. Scaling introduced compounding constraints. Fusion remains technically advancing but commercially unresolved. These technologies did not fail because they were flawed. They failed because reality imposed limits that design could not remove. If success depends on conditions that cannot scale, how close does something have to come before it stops being viable?